You've been hearing a lot about blockchain in the industry, but did you know that we're bringing the power of blockchain to Azure SQL Database and SQL Server with Ledger capabilities? Learn all about it and see a fun demo this week on Data Exposed. Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed. Today, I have a special guest joining us, Pieter, who is a program manager on the databases team focusing on security. Pieter, thanks so much for joining us today. Can you kick us off by telling us a little bit about what you do?
Sure. Hi, Anna. I'm Pieter. I'm a program manager in the data platform security team. That's a team that is managing all the security features in Azure SQL, SQL Server, but also all the other Azure Data Platform services.
Awesome, cool. And it's super exciting to have you on the show today because we're talking about a hot topic, to me at least, and that topic is around bringing the power of blockchain to Azure SQL Database and SQL Server with technologies like Ledger. And this is something really exciting, something that was announced a little bit ago, but for those who might not be familiar with why we might need Ledger or what tampering with data means or how we might be able to find it, can you tell us a little bit more about some of the scenarios for this?
Sure, no problem. I can do that. Now, assume that you have, in your company, you have a SQL database. How can you know that your data that is inside your database can be fully trusted so that nobody actually has tampered with your data? Looking at myself in my previous life, I was a DBA, and I got system administrator permissions on all the systems. So I could easily go into a database and into a table, run some update statements, and nobody would have ever noticed that. Same for authorized users or even external hackers or malware. They can all tamper with your data without you knowing, right? So in the past, we had a few solutions that could help. For example, we have auditing that gives you the context of what actually has changed, but it doesn't give you really cryptographic proof that somebody actually has changed your data. Again, looking at myself, I could easily also switch off the auditing and then do my modification and switch it back on. Once again, nobody would have ever noticed it. We also have temporal tables, which was released in SQL 2016, provides you historical information, but again, you could tamper with that history information as well. So not really good if it comes to proving that your data can be trusted. So for our customers, it was really costly and a manual forensic process to prove that your data can be fully trusted. What we also noticed is that customers, they're looking into blockchain scenarios, but blockchain scenarios are typically overkill for centralized scenarios, right? Blockchain is, it's decentralized, so it has a lot of latency, it has low throughput due to the consensus that you have to make or that the systems have to make, right? It's also resource intensive. You need to have lots of servers, and that goes typically against the sustainability goals of a lot of companies nowadays. We also noticed that customers, they have a lot of challenges for real-world production workloads with blockchain. And what we notice also is that they often go off-chain, which means they extract the data from the blockchain itself, and then they're moving it, for example, into a data warehouse, which means that at that point, your data cannot be trusted. So these are the two scenarios where Ledger comes into play and will help our customers with solving these scenarios. And Ledger is all bringing the power of blockchain with the simplicity of SQL Server. So what we're going to do is we're making the data inside SQL Server tamper evidence by using cryptographic. And when I say cryptographic, it's really cryptographic like we're using it in blockchain nowadays. So we're going to keep track of your historical information of the records. I'll come back to that immediately. And these changes are then, or can be verified through cryptographic proof. It means you can run a stored procedure, or it can be run by an external party, like an external auditor. And you can actually prove that your data can be fully trusted. It's a new feature in SQL Server, so you don't need to, or it's a new feature, sorry, in Azure SQL DB. So you don't need to have a new version of SQL. You don't need to have a different service tier. No, it's a feature that you just need to switch on. It's currently GA in Azure SQL DB. We released GA a few weeks ago at Build, and it's also available in the public preview version of SQL Server 2022.
Awesome. Cool. This sounds pretty promising already. Like, of course, I want more details, but before we get into the details, I wanted to clarify a couple things. One, you said this is just a new feature. So does that mean that, you don't have to pay any extra money for this, or is there a cost associated with turning on SQL Ledger for either Azure SQL Database or SQL Server?
No, it's completely free. You just need to create a ledger table or a ledger database, and that's it. Then you can get started. The only extra cost that you might have is because we need to keep track of the historical records. You might end up with some extra storage that you will have to pay, but for the rest, the feature is completely for free.
Cool. That's awesome. Okay, so how does the ledger work?
Yeah, let me jump into a little bit more into detail. So we have two different types of ledger tables. We have updatable ledger tables and append-only ledger tables. Updatable is meaning we're allowing insert, update, and delete statements on these tables. Append-only means we're only allowing insert statements on these particular tables. So the end user can choose what type of table they want to create. Now, in this example, I'm going to use updatable ledger tables. So let's assume that a user modifies a row in a ledger table, right? What we're going to do is, first of all, we're going to take the old version of that row and we're going to move that into the history table. Not only the values of the row, but we're going to add also extra metadata into it. For example, like the commit timestamp of the transaction, the user that has executed the transaction, and so on. So we're moving that to the history table. And then, of course, we're going to update the record in the updatable ledger table. On top of that, when you create an updatable ledger table next to the history table, we're also going to create a ledger view, which gives you a chronicle overview of the history table and the updatable ledger table. So you don't need to make any specific joins between these two tables. You can just easily use the ledger view. So this is how we keep track of the historical values of your table. But where do we keep the trust of the data? Well, that is done in what we call the database ledger. So for each transaction that is occurring on your updatable ledger table, we're going to hash that in a Merkle tree mechanism into a root hash. Yeah. And then every 30 seconds, we're going to capture all these transactions during that specific period. And we're going to hash them again into what we call a root hash or a block. And then we're going to link that block to the hash of the previous block, meaning we're actually building a blockchain under the hood. And that is how we build the trust. So once we have that block, every 30 seconds, we're going to offload that block to an external storage, to trusted storage. That storage can be Azure Storage account with the immutable settings switched on, or can be a new service, which is Azure Confidential Ledger. Now it becomes interesting because once we have stored these database digests, like we call them, an external party, for example, an auditor, or if you work with a multi-party solution, typically everybody that has access to that database or can execute the verification store procedure. What we're doing is we're going to fetch the database digests from the storage, and we're going to, in real time, recalculate the hash in the database. And then we're going to compare these two hashes, which means if we have a match between those two, it means that the data inside the database can be fully trusted, and we know that nobody has tampered with the data. If there is no match, well, then we are 100% sure that somebody actually has tampered with the data. And the store procedure, the verification store procedure, will also indicate on which transactions the tampering has occurred. So then we are also sure that our data cannot be trusted. So it's really easy for the end user to prove to external auditors, external parties, that the data can be trusted compared to what kind of solutions we had in the past. Like I mentioned, we also have Append-Only, where we block, update, and delete statements. Typically, what we now see, customers are using Append-Only ledger tables to store auditing information. So they just need to have inserts, but they don't need to have any update or delete statements.
Gotcha. That makes sense. Honestly, Pieter, this has been a great explanation. I feel like not only do I understand how Ledger works, but I have a better understanding actually of how blockchain works in general. So thank you for that. I guess my next question, or this kind of leads into, is like, okay, we understand how this works. How do we like create it and set it up and configure all these tables and the ledger and all that stuff?
Yeah, well, it's fairly easy. You just need to specify in your create table statement the option ledger equals on. That's how easy it is. You just only an extra parameter that you need to specify is whether you want to create an updatable ledger table or whether you want to create an append-only ledger table. But that's basically it. Ledger equals on.
Cool. That's pretty nice. So you'll take care of, or the service takes care of all the rest of it.
Exactly. Yeah.
Okay. So then once we've got this created, we're creating, we're just putting updates, append only, whatever, depending on the scenario. How can we go through and verify, like you said, that no one has tampered with the data?
Yeah. For verification, it's a stored procedure that you need to run. The stored procedure is called SP verified database ledger from digest storage. What's in a name, right? Well, to help our customers in the portal itself, there is a button where you can click on which says verified database. And it will give you this specific script. So you just need to open or copy that script into your management studio or your Azure Data Studio and run it. And it will give you a result whether the ledger verification was successful, yes or no. But I will demonstrate it immediately.
Oh, demonstrate. That's what I like to hear. Pieter, is there something you have that we can take a look at?
Sure. Let's have a look. All right. Good idea. Okay, let's start with the portal. What I wanted to show is when you create a database, under the security tab here, there is a new option called Ledger. And when you click Configure Ledger, you have two different options that you can select here. First one is Enable for all future table in this database. When you click this, it means that every single table that you will create in that database will be an updatable ledger table, unless you specify that in your create statement. So sometimes customers, they need to have a database that is fully trusted or fully immutable. Well, then you can create what we call a ledger database. The second topic here, or the second checkbox, is enable automatic digest storage. This allows you to configure your storage account or your Azure Confidential Ledger, as I mentioned before. All right. That's how you can configure it in the portal. Now let's jump into a demo. So we have a website that is used by a company called Contoso, and it's an HR application where, as you can see, it gives you a list of all the employees that are working for Contoso. So it's quite sensitive information. We have the social security number, first name, last name, and also the salary of each employee. Now for Contoso HR, they have a database, and that lady or the database is called Anna Hoffman. And she thinks like for the amount of work that she needs to do, she doesn't earn enough money. So she wants to update her salary. Now, Anna is the DBA, so she has full privileges. So she has system administrator permissions on all the databases.
So Anna, she opens her management studio and she figured out that the data is stored in the Contoso HR database. And what she's doing, she's going to run the query here, and she finds back the record that is related to her salary. So Anna, 50,000, is that enough extra, or you want some more?
I think that's good.
Is that good? Okay.
It's quite a raise.
Yeah, it's quite a raise. I know, it's almost double. Okay, so let's update one row affected. So Anna thinks, okay, nobody noticed it. So by the end of the month, I will have some extra money on my bank account. However, what Anna doesn't know is that we're using, or the employees table is a ledger table that we're using under the hood. So if you go to the Object Explorer here, you can already see here that employees is the updatable ledger table, right? Now, if we go to the ledger view, which is called employees ledger, and we're going to join that with the ledger transactions, then we can actually see here that because of the history table, right, we have two records. So we have, first of all, have a delete statement, and then afterwards we notice that there is an insert statement, right? So first delete, we're removing the old value, and then we're doing an insert of the new value. So this is how we can verify the history table as well. Now, running the verification, as I mentioned, this is just simply executing the stored procedure sp verify ledger from digest storage. So when I execute this, you can actually see the result ledger verification successfully verified up to block 9, which means that, okay, the data that is inside my ledger table, employees, and my database completely can be fully trusted. So we know for sure that Anna has made the modification because we have that proof in the history table, and we have the proof of the verification that is successful. So yeah, Anna, you don't have any other option than just acknowledging that you have actually tampered with the data, or you've modified the salary.
All right.
Oh man, so it seems like I'm not going to be able to get away with this new higher salary because you're going to catch it in the history tables, and then also the ledger was verified. Can you just take a second, because this is the part that a little bit confusing to me, so I want to make sure our viewers understand it as well. Is I tampered with the data, we caught it in the history tables, but why didn't it show up? Why didn't the ledger verification fail?
Because you didn't tamper under the hood. Well, in Azure SQL, that's impossible to do. Or you need to have access to the data files, but nobody has access to the data files. In SQL Server 2022, for example, you have data files. So a malicious DBA could literally go directly into the data file and modify the pages, for example, which means we wouldn't see that in the history table at all. But if we would run the verification afterwards, we would have a mismatch between the hashes. But in Azure SQL DB, we don't have that. So that's why the verification says it was successful, although we know that you have modified the data.
Okay, gotcha. So this is giving us a couple different tools to check so that we can really be sure if anyone's messed with the data or tampered with it in any sort of way. So that makes a lot more sense. Thank you for explaining. I guess as we kind of wrap this episode, I wanted to ask you a little bit about the scenarios and the customers that you're seeing of people actually using Ledger today.
Sure. We see two scenarios nowadays. The first one is streamlining the auditing process. As I mentioned before, you need to prove or cryptographic proof to an external auditor or internally or to regulators that the data that is inside your database can be fully trusted. So that's one use case. The other use case that we see is the multi-party business processes, like supply chains, where you have different suppliers that needs to have access to your data, and they need to be able to verify that every single supplier or every party that we can trust the data between the different parties. So it's an alternative to blockchain system, this one, except of course that we have a centralized solution where the trust is basically decentralized, because of the multi-party businesses. Some customers that are already using Ledger in Azure SQL DB, we have RTGS, we have Lenovo, and we have Code. Lenovo, for example, is using it in a supply chain solution where they need to store parameters of the laptops that they configure. And when an end customer then actually receives the laptop, they're going to run the verification process against that ledger table. So that's why that information in the table needs to be trusted. Code, for example, is a customer in South Africa that is storing healthcare information in the ledger table, like the COVID vaccination status of everybody is stored in a ledger table. If you want to know more about it, we have the links here in the slides that goes to the use case itself of these customers. All right, maybe some other resources for people who want to know more about Ledger. We have a white paper that explains completely in detail how Ledger works. We also have the GA announcement. Of course, we have the Ledger documentation. the two use cases that I've explained. The demo that I've just shown, you can actually show it yourself. So if you click on AKS.ms ledger demo, you're going to our GitHub, where you can download the sources and demonstrate ledger internally, for example, at your company. And we also recorded a podcast on ledger, which explains the functionality of ledger as well.
Awesome. Cool. Well, Pieter, thanks so much for coming on the show. There's been clearly a lot of excitement about this, a lot of resources for folks to go learn more. To our viewers, if you like this episode, go ahead, give it a like, leave us a comment, and let us know what you think of us bringing the power of blockchain to Azure SQL Database and SQL Server. Check the links in the description for all those resources to learn more, and we hope to see you next time on Data Exposed.